the second part of today's lecture, we're going to move on to our next section, which is section 5.5. Section 5.5 is entitled Multiplication of Polynomials. So at this point, think about where we've been. We've added polynomials, we've subtracted polynomials, so it's reasonable then that our next step is to go ahead and multiply them. So example 1 has the directions multiply. And as you look at this, let's go ahead and use some of the terminology from the other day. I have a polynomial here and a polynomial here. This first polynomial is a monomial. There's only one term in that polynomial. And the second polynomial is also a monomial. So I'm multiplying a monomial times a monomial. Now, when I'm multiplying a monomial times a monomial, this actually goes back to things that we've already talked about earlier in the course. So notice that all of these pieces are connected by multiplication. And the same warning that I gave you earlier is still here. Don't look at this negative 4z to the 12th and think about it as one piece that can never be broken. The negative 4 is connected to z to the 12th by multiplication. And because it's connected by multiplication, think about it as that we have a negative 4 sitting here, and then we have a z to the 12th sitting here, a 5, and a z to the 3rd. So instead of thinking about it as two polynomials, I would think about it as four smaller factors. And once I realize that it's four smaller factors, I can reorder these in any way that I want. So same statement that I made a moment ago when we were talking about the addition problems. Some of you are going to need to write down the next step, some of you aren't. So if you don't need to write down the next step, don't feel you need to. So I'm going to take my four smaller factors and just reorder them, because again, multiplication is commutative, so that the pieces that look alike are next door to each other. So I'm going to have a negative 4, and then next door to that, I'm going to put the 5 from the second polynomial. And then we're going to have the z to the 12th from the first polynomial, and the z to the 3rd from the second polynomial. So now we have negative 4 times 5. Because those things look like each other, they can actually come together. Negative 4 times 5 is going to be negative 20. And then z to the 12th times z to the 3rd. This is then one of our rules of exponents. We have z to a power times z to another power. The product rule of exponents says that I'm going to add those exponents together. 12 plus 3 is going to be 15. So this is going to be z to the 15th. And there's our answer. Negative 20z to the 15th. Now, a moment ago I said that if you need to write this intermediate step now, feel free to do so. But as you continue on with section 5.5, you want to get to a point where you can do this middle step in your head. That's going to help you as you move forward in this class, as well as every math class that you go to from this point forward. So you want to get to the point where you can take negative 4z to the 12th and multiply that times 5 to z to the 3rd, and immediately write down that that's negative 20z to the 15th. So as I move forward in this section, I'm going to write fewer and fewer of these intermediate steps just to give you that nudge in that direction. So let's go ahead and try another problem. So for part B then, we're going to check out negative 4p times 3p minus 6. Now, as you look at this problem, notice that we have a monomial in the front here, negative 4p, and we have a binomial in the back. So we're multiplying a monomial times a binomial. Well, as you look at this problem and you think about things we've done previously in the class, if you have a number hanging out in front of a set of parentheses, and then you have either an addition or subtraction inside the set of parentheses, that was an example of a distribution problem. That, in fact, is the exact same thing that we're going to do here. So we need to distribute this negative 4p through to the 3p and to the negative 6. So I'm going to go ahead and write down that intermediate step just to make sure that all the pieces and parts are sitting there. So I have my negative 4p, and I'm going to multiply that times the first term of my binomial, the 3p. And then I have my subtraction symbol, so I'm going to bring that down. And then we have the negative 4p, and I'm going to multiply that times a 6. So now I have two smaller problems that are in fact very similar to what we did a moment ago. We have a monomial times a monomial here, and we have a monomial times a monomial here. So let's see what we see when we bring those two pieces together. So negative 4p times 3p. Once again, what we can do is think about the pieces that look like each other next door to each other. So I have a negative 4 and a 3. Negative 4 times 3 is going to be negative 12. So I'm going to do that off to the side here, negative 12. And then I have p to the first times p to the first. Again, I'm going to write those just to make sure you're seeing them. And if I have p to a power times p to a power, once again, this is an example of the product rule, which means I'm going to add those exponents. 1 plus 1 is going to be 2, so this is going to be p squared. Next off then, we're subtracting a negative 4 times a positive 6. Negative 4 times positive 6 is negative 24. But if I subtract a negative, that's the same as adding. So I'm going to have plus 24. And then I have to think about my p's. So I have p to the first, and then I don't have a p in the other piece. So p to the first multiplied times 1 is just p to the first. So we have then p. As you look at these two pieces then, we cannot bring those two terms together because they are not like terms. One has a power of 2, the other one has a power of 1. So this is all we can do on this particular problem. We have negative 12p squared plus 24p as our final answer. So now that we have that then, we're ready to check out part C. So let's go ahead and do some erasing up here, and I'll put part C at the top of my board. So for part C, let's go ahead and do the following. We have the quantity x squared minus 4y to the third minus 3 times y to the fourth. Now, as you look at this problem then, once again, let's start with a reminder of terminology. The first polynomial is a trinomial. It has 3 terms. And the second polynomial is a monomial. So the reason that I chose this particular example is to simply comment about the fact that distribution works if you have a monomial in front, but it also works if you have a monomial in back. And that's what we have on this problem. So it doesn't really matter where the monomial is. If it's in the front or if it's in the back, it's still a distribution problem. So what I need to do on this problem is distribute my y to the fourth through to all 3 terms in my trinomial. So let's go ahead and see what happens when I do that. So in my first multiplication problem, I have x squared times y to the fourth. Now notice on that one, I have an x as a base on one and a y as a base on the other. I cannot use the product rule there because I don't have the same base in those. So they simply come and multiply next door to each other. So we have an x squared times a y to the fourth there. Well, okay, let's keep going. In my second term in my trinomial, I have negative 4y to the third. And I'm going to multiply that times y to the fourth. Well, negative 4 times 1 is going to be negative 4. And then I have y to the third times y to the fourth. This time the bases are the same. So I can use the product rule. Y to a power times y to a power. I add the exponents. 3 plus 4 is going to be 7. So that's y to the 7th. And then finally, I need to take this negative 3 and multiply times that y to the fourth. Negative 3 times y to the fourth is negative 3y to the fourth. Now what I want to do then is scan through and see if I have any like terms. Now, first off, I see that I have this y to the 7th. I don't have any other terms that have y to the 7th, so that term can't be combined with anybody else. Now, you might be tempted to say that this term has a y to the fourth and this term has a y to the fourth, so those are like terms, but in fact they are not, because this term not only has a y to the fourth, but it also has an x squared. So when I look at this one, I have the y to the fourth, but I don't have the x squared. So I can only combine things if all of the variables are exactly the same with exactly the same power. So since I don't have an x squared in both places, I can't combine those 2 terms. So in fact, I'm done with this particular problem because there's nothing else that I can do in terms of combining like terms. So our final answer then is x squared y to the fourth minus 4y to the 7th minus 3y to the fourth. At this point, we are done with the lecture 31, so you're ready to go ahead and check out worksheet 31 as well as the homeworks 31. Have a great time.